Alright guys, welcome to the next video where we're going to talk about the information control. Now, this one was extremely complicated, okay? Mainly the S1, understanding the S197 is actually very difficult. Once you decompress that, it becomes really easy to translate it to the S550. But let's get into the S197 control and how it works. So the first thing you need to know is that there's a left, right, up, down, and OK in the middle. On the diagram, there is a left, right, up, down, and OK. These do not correspond. They do not correspond with the buttons that you press. Okay? This has to do with the fact that in order to get the LED centered underneath the button, okay, think about the S197 switch where you have that tiny little D-pad, the up button, you want an LED right under that up arrow so you could see it. That means the carbon pill underneath that cannot be right underneath that, okay? It's on the sides. So you have one on the right and one on the left. On the left button, when you have the LED right under the left, you have a carbon pill on the top and the bottom. So what actually happens is when you press up, two of these switches close. When you press right, two of these switches close. So these names here don't actually correspond with the actual buttons, okay? Think about it. When you press left, it is closing multiple different gates. And so what I did was I was able to determine what gates are being closed. So when I press left, okay, I'm actually going to close the left gate and the up gate, which means I end up with no resistors. The circuit is completely shorted, and so I should get a resistance of 0. So when I press left, here it is, a measured and calculated resistance of 0. When I press up, it's going to close the up gate and it's going to close the down gate. So if I go this way, it goes this way, I get a 590 resistance and it goes down to the exit. However, I don't get a 590 measurement because this is creating a parallel circuit of 590 and this 4,320 resistance here. And so you have to calculate the total resistance in parallel. So if I look at it and I press up, I get, actually, not only that, I also have a 715 here when I press that, because remember the down gate closes. So I get the 590, I get the 715, and I get this 4320. So you have to calculate 715 with 590 in parallel and another 4320 in parallel, which calculates out to 301. When I measured it, I get a 300, and my calculated result was 301. Okay? And I've actually shown this diagram here. So if you were to press left, this is the circuit that ends up being completed. If you press up, here is the circuit that's completed. If you press right, it's down and right that get completed. If you press down, it's left and right that get completed. Okay, so that could come off as very confusing, and it took a while. I had to redraw this in a different software called KiCad to actually have it make sense for me. But that is very important. I'll let you guys go into the diagrams, but this is an actual way to see it as I was describing. So when you press up on the key, here is your LED that shines through, but it closes continuity on this one and this one. Okay, when you press left, it closes continuity on this one and this one. It ignores the one in the middle. Don't worry about that. Thankfully, that's only touched by OK. Long story short, it's important for you guys to understand that simply because it allows us to derive these measured values that are the ones we want our S550 switch to spit out when we're actually doing our work. So let's go up to the information control for the S550, okay? Now, luckily for us, the S550 is not this complicated multi-gate situation. It's just like the audio. So we just need to do the same thing with the audio, is we need to rearrange the buttons to have the correct order of, let's say, least to highest resistance. And then we do the same thing as we did with the audio. We'll replace the resistors. If you notice, remember I said the first thing you press is left, it should short to 0. So all you have to do is remove this resistor and put in a trace wire of 0, right? 0 resistance is just a trace. And bring that to the via over here, and that will give you continuity for left. Then after that, you'll remove R5, and you'll take a 400, or sorry, not a 400, a 300 resistor, and go down to the via near up. That means when you press up, you're going to get 300 ohms. Okay, the next one is 300. That's going to go up to right. That 300 plus 300 is going to give us 600. And that's what we want coming out of it, and so on and so forth, right? So as I go through, again, my instructions are very clear. Remove all your resistors entirely, 1 to 6. You're not going to use any of them. So you can see here, removed, 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 removed. Then we're going to add a trace wire to this first one here, to this via, between R4 and R5. Okay, and if you forget which one is, which resistor is which, the labels are over here. So you have 1, 2, 3, 4, 5, and 6. Then you're going to add a 300 ohm resistor to the first pad right here of R5. And you're going to go to the via between R1 and R2. That's here. Okay. Then you're going to, and if you notice here, I left these resistors, these are the original resistance values of the S550. So ignore what's in black on this screen. You only want the resistances that are in the colored. Okay. Then you're going to add a 300 ohm resistor. As I mentioned before, you're going to go to this pad here, and you're going to go over here to 300. Now, since I've done this, I've recognized that you could actually just add an SMT resistor between these to have less of these bar resistors. So I may create another diagram here that makes it a little bit easier for you guys, because this one was tough. There's very little room to do any of this soldering. So the less resistors you have, the easier it will become. I may also say, instead of doing a trace wire here, if you could put a trace wire between these two pads, it will have the same result, because the continuity will be there. But let's stick with this diagram. So you have the trace wire here, then we go 300 ohm resistor here, then we're going to go 300 ohm resistor here. Next we go 400 ohm resistor to the first pad of R4, to the via between R5 and R6. Okay, that's here. And then finally, you're going to add a 1000 ohm resistor between, or going from the first pad of R6 down to the via between R2 and R3. That would be right here. Once again, you don't have to do this. It's optional. Again, I've seen that this works without this, but you can add a resistor, a 2100 resistor from this pad or this pad, doesn't really matter, of these two, over to this via after R6. If you do that, that creates that resting voltage that will allow this switch to work. After I did all of this installation, just so you guys know, after I did all of this installation, this is what it ends up looking like. So I can see my first trace wire here. Okay, then I have my second resistor I talked about that goes back over here. Then I go over here. This is where I said it gets really, really tight, guys. This resistor simply jumps right over here. Moving over, this resistor then comes all the way over here to this one. And then finally, I have this resistor that jumps back over here, which is the last one on the list. Notice that these resistors are vertical. It's because what I did was I took the other leg of the resistor and I stuck it through the via. And that makes it so that I'm not bending wires and the resistors are kind of just sticking out in the 3D space to make it a little bit easier. I did... Oh, and once again, I jump over one of the capacitors or... Actually, I don't know why I added this trace wire here. I think I actually didn't need that, but I added it in for some reason. Yeah, I don't know why that's there. I guess I was doing something. or maybe I removed something and I caused something to short, or I messed up a pin. But once again, here is that trace wire that goes around the diode that allows you to measure at the connector the resistance as you start putting these together to make sure they're working. If you don't add that, you cannot measure your resistance correctly at the connector, because again, your multimeter is not going to provide enough voltage to open this diode. You would have to measure from this from the feed pin, which is this one, to this via over here, which is essentially on this side of the diode. It's not the ground side. These diodes don't exist in the S197, so for now, I assume it's not going to impact it. Before you ask, I did accidentally, as part of desoldering some of these resistors, I did accidentally destroy this LED. I did get a new LED. I have since swapped it in, and it works perfectly fine. So if you get concerned or wonder about that, that's the reason. Also, it looks like I really damaged this board quite significantly. This is before I cleaned it up with the IPA, the isopropyl alcohol. So don't be concerned about that's how it looks. And then the one thing I will add in is this button here. On the premium, it gets subbed in for the sync function. That's a Bluetooth function. I did not build out a schematic for adding in Bluetooth functionality to this connector because it's going to be a nightmare. You don't have enough wires on this connector to go back into or change. Remember when we talked about in an earlier episode, you have the roads. We have 4 roads in the S197. We have our audio control, our speed control, our Bluetooth, which is our sync, and then we have our info control, which is what we're talking about now. Those need to be on distinct driveways or roads in order for this to work with the S197. It will not work unless you replace this connector and get a bigger connector. And I have no interest in getting involved in that. It will have to be done on the wiper switch, but we'll get to that later. So if you want to have the premium switch, you can wire it. It's the same exact way we did this one. The same exact way. Nothing changes. It's just your functionality. You know, this will operate as the right button. This will operate as the left button. And everything will be pretty much the same as the base switch. All right. So that's it. That's how we do the information control. And once you have that fully fleshed out, it will be fully operational. Everything will flow through. I will try to splice in a video. If you get to this point in the video and there's no spliced footage, that means I don't know how to do it. So thank you very much, guys, and I will catch you in the next one.